looking at example 8, now we're going to the casino and we're playing roulette. We've given up on the lottery. Now we're going to go try our luck at the casino. We're playing roulette. And there's 38 spaces. Even if you've never been to a casino, you've probably seen a roulette thing on TV or a movie, right? You spin the wheel and the little ball bounces around and has to land in a specific little spot, right? There's actually a lot of different ways you can bet. But according to this, there are 38 little spaces for that little ball to spin around and bounce into. 38 spaces, 18 of them are white, 18 of them are black, and 2 of them are green. They have numbers on them and stuff too, but we're not worried about that right now. And we're going to bet $5 on black. So we're going to go to the casino, we're going to bet $5 that little ball is going to bounce around and end up in the black square. And if we do, we're going to win $10. Sweet. Double our money, just like that. We want to know, what is your expected value when you play this game just once? What can you expect to win when you play roulette once and you bet on black? What should I do? I should make a table. Anytime they're asking for expected value, I should make a table. Okay, I should make a table. What goes in my table?
X is the number of outcomes.
X is not the number of outcomes, but what the outcomes could be. So,
Like the events, or
like the events, like what would happen if I play this game? I might win or I might lose, right? Yeah, it's either gonna be black or it's not gonna be black, right? But either, and think of it again as how much I'm going to win, or my profit, just like we talked about before. So I might lose my $5, right? If it doesn't come up black.
You might break even.
Ooh, can I break even? I don't know if I can break even. What's it say is gonna happen? Can you pull that door shut, please?
But you can make $10.
I would win $10, but am I making $10? Be careful.
No, you're winning 5.
I'm only winning 5. So this is if I lose. Well, let me just even be more specific. If it's not black, I lose my $5. Right? You agree with that? But if it does come up black, even though they're paying me $10, I paid $5 to play. So do you agree I'm only winning 5? It's always about your profit, not how much they'll hand you, but how much you walked away with that you didn't have to begin with. So if I walk in there, I give them 5, and I walked away with 10, I really only won 5. We agree those are the 2 things that could happen? So now I need some probabilities. And I'm actually really glad that I wrote not black and black right here. Let's do the black one first. What is the probability on this wheel that the little ball lands in a black space? 18 out of 38, she says. What did you say, Kevin? Were you saying the same thing?
I didn't say anything.
Oh, I thought I heard somebody say something back there. No?
Wouldn't it be 50%?
Ah, we wish. They want you to think it's 50%. 50-50? If there only were black and white spaces, I would agree with you, but they threw in those 2 green ones.
That's right.
So if there were 36, 18 black and 18 white, I'd totally agree with you, it'd be 50%. But because those darn green ones are in there, there's only 18 out of 38 that are black. How many of them are not black? 20 out of 38. So they want you to think it's 50-50, which is why everyone keeps playing. But there's actually a little bit more chance that you'll lose than there is that you'll win. Slightly more than 50%. We agree with that? It's a little bit more than half, it's a little bit less than half. So we've created our table, and we want to know what the expected value is. What should I do? Put it in the calculator and find the mean. See if we can all punch that in there correctly. Nice, just have quieted down. I mean, most of us are there. Type in list 1, list 2. One of our stats with list 1 and list 2. What did we get? It says X bar on your calculator, but it's our population mean.
It's like negative 263, and then there's a chunk numbers.
Negative 263. Is it round to 6.3 or 6.4?
6.3.
0.263.
Oh, 0.263?
Yeah.
So 0.26 if I'm talking money. I'll round it to the cents place if I'm doing money, right? 0.26. What does that mean every time we go to the roulette table to try to win? We're losing 26 cents every time we play. Even though sometimes it comes out black and they give you $5. 5 extra bucks, they give you 10, but it's 5 extra. If you keep doing it over and over, every time you play, on average, you're losing 26 cents. You ever been to a casino? They've got free drinks, they've got all these lights and sounds and all this cool stuff. Guess who pays for it all?
We did that 26
We do.
cents.
26 cents every time the roulette thing goes around. And that's if you bet only $5. People that bet a heck of a lot more than $5 are giving them even more. If you bet $50, you're multiplying that by 10, right? You're losing a lot of money. Casinos aren't paying for any of that. We all are. They're not really free drinks. And they're watered down, too.
It's cheap alcohol.
Cheap alcohol, yeah. Cheap alcohol, less
You're really
alcohol.
losing all the way.
And we're paying for it. Other than that, it's a great time. Questions on that? Yes.
So if you threw another variable into that, like say you chose black, but you put like a number on black, like black 17, how would you calculate the probability?
Okay, so let's say you wanted to pick a specific number.
Sure.
So let's say he wanted to be the 17, which happens to be black. There's only one black 17 out of the 38.
Uh-huh.
So your probability would have been 1 out of 38.
Would it have been 30? Oh, yeah.
And because there's 38 spaces. And then the probability of losing would have been 37 out of the 38. Either you win or you lose. Actually, I have it backwards.
So the green one still matters?
Well, they're in my 38.
Oh, I thought it was 36 and then.
It's 38.
1 out of 38.
1 out of 38 would be your probability of winning. And then obviously there would be a 37 out of 38 because all of the other ones would not be your black 17. And the difference is to make you want to try this, the payoff is much higher for this. Like if you bet $5, I don't know what the payoff is. The payoff might be $100. But it's still not enough for you to come out ahead in the long run. So the more unlikely of the event, the smaller the probability, the more the casino pays you. Because it's hard to pick the exact one it's going to go into. So if you do, they're going to give you a lot of money. But they know the chances are so slim. And having those 2 extra green ones are what do it. They essentially ignore the green ones when they figure out how much they're going to pay you and know that every time it lands in the green ones, they win.
You can't bet green, can you?
I think you can, and the probability is, again, really small.
Right.
And so again, but the payoff's not enough that the expected value would come out positive for you ever. The casinos don't ever set it up in a way that you will come out ahead of them. We could spend hours, days, talking about all the different ways they set their probabilities and how it's so close to being 50-50, like you said, but just off enough to make it so it's in their favor. Yes?
There was the one time I went to the casino and the person next to me won $1 million.
Yeah. So somebody next to her won $1 million at the casino. We're not saying people don't win, but guess who paid for that person's $1 million? The rest of us. We all lost, and on average, and then that person. So that person thinks, wow, this is a deal. I can get rich. But if that person keeps going back over and over again and reinvesting their $1 million in the long run, they're losing every time. When you go up ahead, then you end up down at the end. It's quite sad. That's why people have gambling problems. But speaking of other options, there is, I think, at least one homework problem where you need to make a table like this where there are more than one thing that could happen. Like if you entered a contest where maybe you'll win $50 or maybe you'll win $100 or maybe you'll win the grand prize of $500, you might have more options here. Like maybe you could win, let's say it was free, let's say we paid $1 to get in, so you might win 50 or you might win 100, so that'd be 99. These are your profit if you paid $1 to join in. These are all the winnings. Maybe you have more than one, or maybe you could win $1,000, which means really $9.99, or you lose your dollar. Maybe these are all the things that could happen. You win $50, or you win $100, or maybe you could even win $1,000, or maybe you lose your dollar for entering.
So
It's
you always-
possible.
You always
Yes.
have to subtract the one from what you paid.
Exactly. You always have to subtract the one, consider there is the option that you might lose. And they might tell you, oh, the chances of you winning this $50 is 1 in 100. They might give you that probability. They even actually say that on the back of some sweepstakes forms where they tell you the probabilities of winning the certain things. And the chances of winning the $100 is 1 in 1,000. And the chances of this is 1 in 10,000. I'm making these up as I go. Oops, maybe it's 100,000. I put an extra 0 on there. So they might give you those probabilities. But they don't give you this one. Could we find it?
Yeah.
Could we find that one if we don't have it? You'll be asked to do this. Sorry, who was saying
Well,
what?
they just equal to.
Uh-huh, they have to add up to 1, remember? So how can I find what goes here?
When you subtract it like you did. before.
Exactly, add all these up, get whatever that is, and subtract it from 1 to see what's left. This number that goes in here will be 1 minus whatever those add up to, which I'm not gonna do the whole problem right now, I just wanna give you a heads up because you're gonna see one on your homework. We agree that if I add those all up and subtract it from 1, I can see what goes in there? And then I can find the mean and go from there. So sometimes there are more than one possible way you could win. There's still a lot more chances that you're gonna lose. Everyone all right with that little heads up? Questions? What's the expected value? Mean, thank you. The mean is the expected value is the mean.